Okay, this study is focused on the stress on lateral compartment after the medial mobile UKA. And so after the UKA operation, the alignment can be neutral, varus, or valgus. We don't want to get alignment with valgus because we worry about the lateral side heart pressure and progressive OA, and that's the major cause leading to the failure of the UKA. And many literature has been recommended the neutral or under correction for a medial UKA to avoid increasing pressure on the lateral side. And so the question one, what is the optimal postoperative alignment for mobile bearing UKA? Neutral or reduction, or under correction, or both. And technically, when we perform the UKA, sometimes the tibia tree can be a neutral or varus or valgus. So the question two, does the inclination for tibia tree influence the pressure on the lateral sides? And also we want to know what is the proper coronal alignment of a tibia tree, neutral, valgus, or varus. So this study was to analyze the effect of post-operative alignment and inclination of the tibia component in a coronal plane on the lateral cartilage stress after medial mobile bearing UKA. And a validated finite element model with intact knee was used for this analysis. And modular of elasticity of the joint items compared to the close to the natural knee joint, respectively. And there are a variety of finite element models, and this three without the femoral part. And Kuhn report the very good the model with an intact knee structure in 2014, but the bone is solid. And this is our model, and this model with some special features. Meniscus cartilage of lateral compartment is convenient for analysis of the contact stress on the cartilage in lateral compartment. The major ligaments for testing the ligament stress, and the bone structure entity including casulus and cortical bone for analyzing their stress strain respectively. Now loading input from femur, so the load distribution is even. So the method one, we check the lateral cartilage stress by the investigated alignment of three positions, the neutral and valgus, 3-degree valgus and 3-degree varus. And the test two, we test the lateral cartilage stress to study the inclination for tibia components in the neutral or valgus 4-degree or varus 4-degree. The results. Comparative analysis for normal knee joint and UKA model with neutral alignment and axial loads. We found the peak value of contact stress in lateral femoral cartilage and tibia cartilage is higher than the normal knee joint. So we found the lateral cartilage stresses increase in neutral position for the alignment, and the stress will be high in the 3-degree valgus. And the inclination of a tibia component in the coronal plane does not affect lateral compartment stress. So no matter what position of the tibia tree placed in neutral, varus, or valgus, the lateral side pressure did no big difference, almost the same. And in the literature, this literature also demonstrates when overstaff or in the balanced UKA, the lateral pressure was increased compared to the native one, but understaff UKA is almost the same to the native one. And this the kinematic study demonstrates understaffing the modal component leads to the kinematics close to the native knee. And this lecture showed us the different varus vargus alignment of a tibia tree that does not influence the lateral size pressure in different degree of vargus and different varus and even the neutral position. Almost the lateral pressure is almost the same. But one thing we should pay attention, if we put the tibia tree in the valgus position, then the conjunction between the sagittal and the transverse cutting area will get the very high pressure localizedly, and it's easier to get the fracture. So we should pay more attention. So conclusion of our study, that our data suggests that end-correction for alignment should be recommended for medial mobile bearing UKA. The inclination of a tibia component in the coronal plane does not affect the lateral component stress, and perpendicular coronal tibia position should be reasonable. And finally, the end correction is recommended for mobile bearing UKA. Thank you. Thank you for your attention.